Good day. I am Derrick Hogan with North Georgia Technical College here at our campus in Clarksville, Georgia. I have a little something I want y'all to look at today, and we'll take a look at see if we can determine if this part is a CNC part or a manual part. In this case right here, there's ways to do it both ways. There's advantages to do it both ways. Let's step inside and see what we got.
Okay, now I've moved over to the mill to do this. Now I'm going to need some way to clamp this down. I can put it on my rotary table, but I have to have some means to clamp it. The problem about clamping is the machining I need to do is out here in this area right here. As you can see, this one does not have a bore here that I can actually thread anything into. So what I've made is the plate I made earlier. It's going to go in here. It's going to screw down to these holes right here. We're going to drill and tap this right here to allow us to put this plate up here and be able to clamp our piece down and be able to do the machining that's necessary on it. Okay, indication process on a rotary table. One thing I like to do with these right here is I like to go ahead and kind of get myself roughly aligned before I start. So what I'm going to do is bring my indicator tip and get roughly aligned with that concentric ring that you see right there, a little bit above the surface. If you look at it from this perspective right here, it's roughly aligned there. So what I would do then is zero out my readout there. And I'm going to swing it around 180 degrees. Now when I get 180 degrees, you should be able to see that it is off visually here. So what I would do is then move it over till it lines up. This is a rough alignment that gets me a bit indicator of travel. And then I want to see what my readout says. My readout says 68 thousandths here. So half of that would be 34. So I bring it back to 34. Zero out my readout. And then I'm going to come back over here again, realign this. Best I can tell. Swing it around 180 degrees. Look and see how it looks. It's still a little bit off. So I'm going to go back over the rest of the way there. I have a readout of 38 thousandths again there. So we'll go half of that. Which would be 19. Then repeat the process there. Swing it around. If you see that there, it looks like it's tracking pretty good. The whole purpose of this right here is just to get myself within indicator travel. Okay, now I've got my indicator down in my hole, and I'm going to take a look and see how this runs. We'll zero out my indicator. And we'll swing it around 180 degrees. Not quite touching enough. Let's get over a little bit more. There we go. Zero out. Good. Right here I have about 2 thousandths right there. So I'm going to zero out right here and swing it around 180 degrees. So let's go around here again. And shockingly, I am on about half thousandths out. Now, if I look right here, I can always see it's only moving one direction, so that's not a true reading yet. So put myself a little bit more preload in it. I'm close. I can tell that, but it's not that close. Let's re-zero one more time. Swing it around. That's more like it. So doing what I did there, I got myself with 2.5 thousandths. I started off pretty good with this. So I'll move back half of that. Re-zero. Swing back around. Check it one more time. So split that in half again. Breathe 0. Come back around here to this other side. I'm about within about a half thousandths or so. Half thousandths is pretty good for what we're doing in this situation. Okay, now I need to roughly center this up. I usually have my students make a center like this right here. You can drop down in here and use it to align it for rough alignment. In this case, this will be sufficient for what we're going to do because this is not going to be, there's going to be no locational features on this. It'll just be for clamping purposes. So once I get the clamp to a position, I bring it down into the hole. It's going to help me push it over into alignment. So now what I will do is clamp these these screws I have here. Right over here. And our fixture plate or subplate is ready to go. What others say before I put this up here and start working on machining this? I need to have a way to locate it. Now what I'm going to have to do is clamp this up here using the center bolt here, and then basically go about positioning it using the outside. I could do that. If I'm doing just one of that would be fine. But if I'm doing more than one of these, I want to have it a little bit more accurate to start off with. I could machine a pocket down in here that this would fit down into. That would work. That'd get me usually within the tolerances that we're looking for. But another thing I could do here is, if you see these right here, these rings in the surface of the rotary table, I'm going to go about cutting a ring here. So what I'm going to use is a small ball nose end mill. I'm just going to move over 2 inches because this is going to be a 4-inch diameter piece, 2-inch radius, and then I'm going to go down and make a light little cut around here just to create a ring that I can use to help visually locate this, which will allow me to get within indicator travel. Once you get an indicator travel, getting yourself actually indicated in is a lot more accurate. Another way I could do these, if I was making more than one of these, I could have machined this entire surface down and left a 1.5 inch diameter ball there that would locate the piece. So I get my ball nose mill down close. I come over here to my digital readout and move over 2 inches on the radius on one axis here. A lot of times I'll make a plate like this and just leave it on the machine, leave it on the rotary table as a way to clamp stuff down. It also has the advantage of being able to actually machine down into the surface as necessary. Okay, we'll lock my X and Y axes down here. They may shift a little bit. In this case, we have a 6-tenth shift on my X and a little bit of shift on my Y, so I'll move this back a little bit here. That is normal. It's annoying, but normal. Sometimes it's worth chasing down, sometimes it's not. So now I have this down here. What I'm going to do is feed this, turn my spindle on, feed this down until it touches and makes a light cut, and then travel using my rotary table here to move around this 360-degree circle. So when I was doing the little rig here, I noticed something about it. I noticed that it was not completely flat. So what I did do is deck this down to allow us to have a flat surface to work off of, so that's your holder piece. And then I went about machining our ring into it right here. This ring's purpose right here is just going to be to help with the alignment pieces. I've added a stud to the center. And what I'm going to do is take my piece, drop it down on top of it right here, line it up as best I can visually with that ring that I've machined into the surface. And remember, the whole purpose of that there is just to give me a visual guideline. I'm going to take and use one clamp bolt. One clamp bolt is going to go on top right here. I'll tie that down with a wrench and be good to go. This is going to allow me to be able to clamp it. Now, I always tell my students, when you're clamping something, always use at least 2 points of contact. You could use one clamp in the center of a bore like this because it's establishing 2 points of contact. 1 point of contact becomes a great pivot. 2 points of contact actually becomes a safe work holding device. Next thing I do is I gotta align this piece to my rotary table. Well, what I want to do here is I want to take my digital readout back to 0, which my 0 here is the center line of the spindle above the center line of the rotary table. My part is been aligned using that ring that we machined into it to basically help us align it. So what I got to do is get my indicator mounted. I have it zeroed out here on the back, and I am going to swing it around to the front. And I will see indicator movement here. And I'm about 4 or 5 thousandths. That's a whole lot better than not being with an indicator travel at all. So what I've got to do now is figure out which way I need to go with this. Now, one way I can tell is by pushing my indicator. If I push my indicator away from it, you see how it moves the same direction it just moved. That means this is too far this way. So what I need to do is bump this back half what I see here. So I see 6 thousandths roughly, about 5 thousandths actually. I'm going to bump it back here to get it aligned properly. See how the back bumped it out of the back. Got 2.5 thousandths or so. I'm going to re-zero and swing it back around to the back side here. Okay, I like working one direction here, so I'm going to re-zero this right here again. Bring it to the front. And I'm about a thousandths out. So we'll bump it back. Half that amount. E0. Swing it to the back. Double check and see where you're at. That's pretty good right there. Now if you see it's not touching here, so I'm not aligned fully. I'm aligned in one axis here, which means I probably have to go back and repeat this process. What I can do right now is lightly tap this right here back to 0. The reason why I went back to 0 is I had 0 here and 0 here. So swing it back around and see how we are now. And pretty close, but a little bit out. So I'm going to re-zero here and work my way back a little bit more. Go back around over here, and I'm gonna call that about 2.5. Bumped it back, re-zero again, swing around. So I'm getting 0. Pretty close to 0 here, about a 0.5 thousandths out here. If I come up here to the front, I'm showing about 2 thousandths out. So I'm going to see if this piece is round. There's a possibility this material is not completely round. So I got 0 here. We'll come around to the back here. On the back here, I am pretty close to 0. It's about 0.5 thousandths out or so. Maybe 1 thousandth. This piece is not quite 100% round, but it's pretty close. I'm going to clamp it and go work right here. Now if I look at the blueprint on this, I see I've got a 3 1/4 diameter here on this feature right here. That's be our first feature I cut here. Now what I want to do this is divide that by 2, which will give me the radius here. The radius will be 1.625. Now I need to add to it the diameter of my cutter. I'm going to use a 1/2 inch cutter, the radius of my cutter, so that'll give me 1.625 plus 0.25, that give me 1.875. So that's what I want to set for my finishing pass, my Y or X axis. Either one, not both, but either one in this case. In this case, I like working off my Y, so I'm going to move it up to the 1.875. Once again, that'll be my final cut here. So I'm going to go probably closer to like 2 inches for starters here. Still 1.95. 1.95 should let me be close enough without being too far away. And I'm going to start feeding down, thinking about making my cuts. So I've got my cutter mounted. I am about ready to go. Things I need to do now is I need to touch off on the top surface of the workpiece. I've got my readout at roughly 1.95, which is going to allow me to be inside the workpiece, but also not have to worry about hitting on these screw heads. I have a total depth here of a 1/2 inch. So I'm going to go about cutting down to about 490 thousandths in several cuts. Once I get down to 490, I'm going to start stepping my way over to get to my 1.625 plus 1/4 inch, which can be 1.875 diameter. Then I'll go about finishing it out from there. You see I made a little bit of a mess since we last talked. I've got it roughed down to depths and roughed down to diameter. Right now I'm at 1.89, so I should have about 15 thousandths on the radius to take off of this right here, which should give me 30 thousandths on the diameter. And I'm at 490 thousandths here, so I should have about 10 more thousandths of depth there. I'm going to verify my diameter here and make sure that that is correct before I go any further. As you saw, my diameter and my was correct there, so I was basically 30 thousandths away like I was expecting it to be. So what we'll do is turn my spindle back on, dial over the 15 more thousandths, 875, and dial up the 10 thousandths on my Z to go about machining this to finish the dimensions. The next thing I need to do is cut this 60/1000 chamfer around this outside edge. Now, this is going to be one of the things right here. This piece right here is going to be a little interesting how we chamfer this. But this outside edge will be pretty straightforward. First, I'm going to use the chamfer tool, which I already have mounted over here. And I'm going to bring it down to where it touches off on the quarter of the piece. And I'm going to feed myself down 60/1000 to get to my final depth there. So one thing I wonder if you noticed, I am doing a conventional pass to do the removal of the material because there is no ball lead screw here, so it can't handle backlash. But then I'm coming back with a climb mill pass to clean up the surface. And that's doing a much better job of giving you a much smoother finished surface on the piece. The next feature I'm going to go about Machinist is 1 inch radius right here. It's cut at a distance of 2.25 from the center here. This could be on the center here. There's going to be 1, 2, 3, 4, 5, 6 of these cut. I'm only going to cut one just to show you the process, but the process will repeat itself for the rest of these. It would be very similar to that. I have to do a little math here. First off, I measured the diameter of this right here, and it came out to be 1.965, which is roughly 50 millimeters, so it's more likely 50 millimeters, what it originally was supposed to be. Well, I took that 1.965 and I divided by 2, and I got 0.9825. If I subtract that from 1 inch, I get 17 thousandths. So I need to have my cutting tip here to be set for 2 inches to be 17 thousandths different than this right here. Now that's on the diameter. So I got to divide that by 2, which should give me my radius, which in this case would be 0.008, about 8.5 thousandths or so in this situation. So I gotta have an 8 thousandths variance there. That's gonna allow me to set it to this radius here, preset it to this radius. So what I'm gonna do is start bigger than this right here and start working my way over and plunging down until I get to the 2.25. So the next step I do is I bring it down and make contact with this right here, and I'm going to zero this out. This point right here. And we'll move it up my, let's call it 9 thousandths. 9 thousandths. There. So I'll move this back, and what I need to do is get my cutting tool tip. So my cutting tool tip is at 9 thousandths away. I'm close right now, but I'm a little bit high. So what I'm going to do is take this out and back this down. Also, when you're doing this, make sure that it is aligned properly this way right here. That way that you don't end up with some getting a false reading. Okay, the next part of this right here, I've moved over off my piece. I'm about 2 5/8 away from my piece there. That's going to allow me to be able to find where I need to start. Now what I want to do first is bring this down until I'm almost touching right down here. A little bit clearance is okay, and I am just about touching, as you can see there. I will finish that up later whenever I actually go to do my finishing pass here. And the next thing I'd want to do is bring it to our rub right here. I'm going to turn my spindle on and get it to where it touches off on this diameter right here. And then I'm going to worry about getting it to touch off here when I go to do my finish pass. So then what I'm going to do is start stepping myself over and feeding down different amounts until I get to that 2.25 dimension that we have there. Turn my spindle on. And start moving over to my touch. I'm touching right there. So raise myself up. dial my stuff over. I'm gonna start off about 20 thousandths. I'll go up from there once I get a feel for how this is gonna cut. You can see, man, that cut pretty easy. So I'm gonna go about 30 thousandths. Still pretty good. Go about 40. Looks like about 40 or 50 is going to be right about what it can handle. So I'm going to go 50 on this one, and that'll probably be where I top out. Now I've got all my roughing passes done. I'm going to do my finishing pass right here. So bring it down, engage, let it feed in. Repeat the process. I usually repeat my finishing pass twice to cut out any push off that occurs. One more time. That's pretty good right there. Now, if you look, I'm right at 2.250. One size is off. But I'm right there at what this would be dimension there. This is if you notice, this is a 2 decimal place dimension here. So tolerance would be more likely about plus or minus 10 thousandths here. Now what I'm going to do next is start to feed back here. I'm going to unclamp my x-axis. I'm going to start feeding back here. It's going to basically kind of face that off the rest of the way. Now my next step here is I'm going to bring this up until I just lightly touch here on the surface. I'm going to feed back over to my 2.25. Since I am doing this on a rotary table, I could go about dialing it over to my next position, the 60 degrees to my next position, and go about cutting it. But for what I'm going to do right now, I'm just going to go onto the chamfer here and cut the chamfer on this feature right here. Because if you look at the drawing here, one of the challenges to making this piece using manual machining methods is the fact you have this chamfer here. So you got to duplicate this chamfer. So now I've got this roughed out. I've got the bore cut to get the radius on there. And what I need to do for my last little piece of this right here is I need to cut a 45-degree angle on this right here, the surface right here. And then I'm going to open this up a little bit more so this will cover the radius we're trying to do the chamfer on. Now if you look at it right there, you can see I've ground this to be a 45-degree angle. It has relief cut onto it that's going to allow it to have clearance to go back cutting. Now the next thing I would need to do is get this point goes right here where it's going to cover my 2-inch diameter. So if you remember earlier, we set this heights gauge to be at the 2-inch point. So what I'm going to do right now is break up this cutting edge right here all the way up to where it's basically right about that edge there. That's going to allow me to have the ability to cut the chamfer on the piece. So I've adjusted it up, and you can see how my 2-inch is going to give me enough clearance there to be able to cut a piece. The last step, so this one feature right here, is I'm still at my dimension, my 2.25 dimension, and I'm going to bring this up until I lightly touch, zero out, and then I'm going to raise it up 60 thousandths to go about cutting my chamfer. Raise her up. There you go. Now I can go about continuing this process to do the rest of these. I would have to redo my clamp situation here, and these right here would potentially interfere with the cutter here. So there's some problems to finishing this this way right here, but it gives you an idea about how you could go about doing the basic machining of a piece that you might not would have considered doing it on a manual machine.
Once again, I am Derrick Hogan with North Georgia Technical College in the CNC Technology, Precision Machining, and tool&die programs. We are working with Practical Machinists to collaborate to make some educational content videos. If there's anything you would like to see, leave a comment in the comments below with any ideas that you may have. And also don't forget to like and subscribe for additional videos.